The Ice Age did not kill the megafauna. This is the argument that has been building in the paleontological literature for 60 years, and it is the argument that the evidence, examined carefully and without the comfort of alternative explanations, most strongly supports. The Ice Age ended, the megafauna died. But the Ice Age had ended before, many times across multiple glacial cycles spanning hundreds of thousands of years, and the megafauna had survived all of them. Every previous warming, every previous climate shift, every previous transformation of the steppe ecosystem into something different. They survived all of it, until one thing changed that had never changed before. In 1966, a geoscientist at the University of Arizona named Paul Martin published a paper that made an argument so uncomfortable that parts of the scientific community spent the next several decades trying to disprove it. The argument was simple. The argument was precise. The argument has not been successfully refuted in the 60 years since it was made. Martin called it the Overkill Hypothesis. The argument was this: the Pleistocene megafauna extinction was caused primarily by human hunting, not climate, not disease, not cosmic impact, humans. Specifically, the arrival of anatomically modern humans, Homo sapiens, equipped with projectile weapons, coordinated hunting strategies, and no prior evolutionary relationship with the prey they were hunting, into ecosystems that had never experienced a predator of this type. The megafauna did not know what humans were. That was the problem. The evidence for Martin's hypothesis begins with a pattern so consistent across different continents and different time periods that dismissing it as coincidence requires more explanation than accepting it. The pattern is this: wherever anatomically modern humans arrived, megafauna extinction followed. Not gradually, not over millions of years of climate pressure, rapidly. Within 1,000 to 2,000 years of first human contact, the large fauna of a region underwent catastrophic collapse. The timing, continent by continent, tracks human arrival with a precision that climate models cannot replicate. North America, humans arrived approximately 13,000 to 15,000 years ago. Within 2,000 years, 35 genera of large mammals, including woolly mammoths, mastodons, ground sloths, horses, camels, saber-toothed cats, and the American lion, were gone. Gone, not reduced, gone. The continent went from one of the most megafauna-rich environments on Earth to the relatively impoverished large mammal assemblage that exists today. And it happened in what is, geologically speaking, an eye blink. South America, same pattern. Humans arrived, megafauna collapsed. The timeline matches. Australia, humans arrived approximately 46,000 to 50,000 years ago. The Australian megafauna, including Diprotodon, the largest marsupial that ever lived, Procoptodon, a giant kangaroo standing 2 meters tall, and Thylacoleo, the marsupial lion, disappeared within the subsequent millennia. The Australian extinctions predate the end of the last ice age by tens of thousands of years. Climate cannot explain them. Human arrival can. Africa and Asia are the exceptions that prove the rule. In Africa and Asia, where Homo sapiens evolved and where large mammals co-evolved alongside human hunters over hundreds of thousands of years, the megafauna survived. Not entirely, there were losses, but the proportion of megafauna surviving in Africa and Asia is dramatically higher than in the regions where humans arrived suddenly as a novel predator. The African elephant, the rhinoceros, the hippopotamus, the Cape buffalo, These are the animals that evolved alongside human hunters and developed appropriate fear responses and behavioral adaptations. They survived because they had time. The megafauna of North America, South America, and Australia did not have that time. Paul Martin's most compelling evidence is what he called the naivety problem. The megafauna of North America had no evolutionary history with bipedal primate hunters. They had evolved over millions of years alongside their actual predators, saber-toothed cats, dire wolves, American lions, short-faced bears. These were the animals they had developed fear responses to. These were the animals their behavior was calibrated against. A group of humans with spears was not in their behavioral library. This is not speculation. We have direct evidence of it. When European explorers arrived in regions that had been isolated from human contact, the Falkland Islands, various Pacific islands, parts of the Antarctic, they documented large animals that showed no fear of humans whatsoever. Birds that could be picked up by hand, seals that watched curiously as hunters approached, animals whose evolutionary history contained no reason to treat a bipedal primate as a threat. The same behavioral naivete that made these island animals vulnerable to 19th century hunters almost certainly characterized the megafauna of North America and Australia when humans first arrived. A woolly mammoth that had never encountered a coordinated hunting party with projectile weapons had no reason to run. By the time enough individual mammoths had been killed to constitute selective pressure for fear responses, the population was already in collapse. 1,000 years is not enough time for evolutionary adaptation. It is enough time for extinction. Martin developed what he called the Blitzkrieg model to describe how this process would have worked. The model has been criticized, refined, and debated extensively. Its core prediction has been repeatedly confirmed. The model proposes that a small founding population of human hunters entering a region of naive megafauna would have caused a wave of extinction that moved across the continent at a predictable rate. Not because humans were numerous, the founding populations were small, but because the prey was naive, the hunting was extraordinarily productive, and the human population grew rapidly on the surplus. The mathematics are straightforward. A mammoth produces one calf every 4 to 5 years. A human population growing on abundant food can double in 20 to 30 years. If hunting mortality exceeds birth rate by even a small margin, the prey population collapses. And with naive prey that does not flee, hunting mortality can exceed birth rate by a substantial margin without requiring large numbers of hunters. Simulations of the Blitzkrieg model, run with conservative assumptions about human hunting efficiency and population growth, consistently produce extinction timelines in the range of 500 to 2,000 years. This matches the archaeological and fossil record. The climate hypothesis has not conceded. Its proponents make legitimate points that the overkill hypothesis must account for. The first is the survival of some large species. Not all megafauna went extinct. Bison, moose, elk, and caribou survived in North America. If human hunting was so efficient, why did these animals survive? Martin's response is that these animals were either less susceptible to the specific hunting methods of early humans, or that their populations were large enough to absorb hunting pressure without collapsing, or, most importantly, that they coexisted with humans in Eurasia before the Americas were colonized and had already developed some degree of behavioral wariness. The second counterargument is the lack of direct kill sites. We do not have abundant archaeological evidence of humans killing mammoths and ground sloths. If humans were killing these animals in large numbers, where are the kill sites? This is a genuine evidentiary gap. Martin's response is that kill sites are rare in the archaeological record generally. Carcasses are consumed, bones scatter, preservation is imperfect, and that the absence of evidence is not evidence of absence in a fossil record that preserves only a fraction of what actually happened. The third counterargument is the simultaneous climate shift. The end of the Pleistocene was a period of genuine climate change. Temperatures rose, habitats shifted, the steppe ecosystem that supported the megafauna contracted. Is it not possible that this climate pressure, combined with human hunting, produced the extinctions? Yes, Martin acknowledged, it is possible. It may even be probable. The question is not whether climate played a role. The question is whether climate alone can explain the pattern. And the pattern, the continent-by-continent correlation between human arrival and megafauna collapse, including in Australia, where the extinctions predate the end of the Ice Age by tens of thousands of years, cannot be explained by climate alone. Paul Martin died in 2010. He spent 40 years refining his hypothesis, responding to critics, and watching the evidence accumulate on his side of the argument. He was not triumphalist about it. In interviews toward the end of his life, he described the overkill hypothesis as the most depressing conclusion he had ever reached. The reason is what the hypothesis implies. If Martin is correct, and the balance of evidence suggests he is more correct than not, then the Pleistocene megafauna extinction is not a story about climate change or cosmic impact or natural cycles of extinction. It is a story about us. It is the first chapter in a very long story about what happens when Homo sapiens encounters ecosystems that have not developed defenses against us. The woolly mammoth was not killed by an ice age. It was killed by the same species that is now discussing whether it can be brought back through de-extinction. The irony is not subtle. The overkill hypothesis is not merely historical. It makes predictions about the present. The species that are most vulnerable to human pressure today are the species that have had the least evolutionary time to develop appropriate behavioral responses to human hunters. The large, slow-reproducing megafauna of Africa and Asia that are declining toward extinction despite millions of years of coevolution with human hunters, because the hunting pressure they now face far exceeds anything their evolutionary history prepared them for. The African elephant, the rhinoceros, the hippopotamus, the great apes, the large cats. These are the descendants of the animals that survived the first wave. They survived because they had evolutionary time to develop some wariness of humans. They are now losing that advantage as hunting technology and habitat destruction accelerate beyond any evolutionary response time. Martin's hypothesis does not end in the Pleistocene. It ends here. It ends with the sixth mass extinction, the one currently underway, the one being driven by the same species that arrived in North America 13,000 years ago with spears and no particular intention of causing the worst ecological catastrophe since the asteroid. The Ice Age giants disappeared because of us. The question the overkill hypothesis leaves us with is not historical. It is, what are we going to do about the ones that are left?